am going to talk about interstitial fluid.
At the arterial end of the capillary, the net filtration pressure is equal to the net hydrostatic pressure minus the net osmotic pressure. The net filtration pressure is 13 millimeters of mercury. This causes fluid to move from the capillary into the interstitial fluid. At the venous end of the capillary, the net filtration pressure is equal to the net hydrostatic pressure minus the net osmotic pressure. The net filtration pressure is minus 7 millimeters of mercury. This causes fluid to move from the interstitial fluid into the capillary. Approximately 9/10 of the fluid that leaves the capillary at its arterial end re-enters the capillary at the venous end. About 1/10 of the fluid passes into the lymphatic capillaries and returns to the bloodstream via the lymphatic system.
The fluid found in the intercellular spaces composed of water, amino acids, sugars, fatty acids, coenzymes, hormones, neurotransmitters, salts, and cellular products. It bathes and surrounds the cell of the body and provides a means of delivering materials to the cells, intercellular communication, and removal of metabolic waste. On average, a person has about 11 liters of interstitial fluid. Pros. The balance between the two forces differs at different points of the capillaries, with the hydrostatic and the osmotic pressure. Interstitial fluid bathes the cells of tissues. This provides a means of delivering materials to the cells, intercellular communication, as well as removal of metabolic waste. To prevent a buildup of tissue fluid surrounding the cells into tissue. The lymphatic system plays a part in the transport of tissue fluid. Tissue fluid can pass into the surrounding lymph vessels and eventually ends up rejoining the blood.
Blood pressure forces a watery fluid from capillary walls into tissue spaces. Most of this fluid re-enters the capillaries, while the remainder passes into adjoining lymphatic vessels as lymph. Red cells remain in the blood capillaries, and some white cells pass out to act as scavengers. Some materials flow out of the capillaries by way of diffusion. Other materials, through pores of varying sizes at junctions between capillaries.
Cons. Sometimes the removal of tissue fluid does not function correctly and there is a buildup. This can cause swelling, often around the feet and ankles, which is generally known as edema. The position of swelling is due to the effects of gravity.
Edema means swelling from fluid that accumulates and is trapped in your body's tissues. Edema most commonly occurs in the feet, ankles, and legs, but any part of the body can be affected. The tissues of your body are made up of cells held together by connective tissue. The space between cells that contain connective tissue and tiny blood vessels is called the interstitium. The fluids in your body that are not inside cells are usually stored in your blood vessels and what are called the interstitial spaces, meaning not inside cells. Edema occurs when the tiny blood vessels or capillaries leak fluid into the surrounding tissue spaces. When the interstitial spaces fill with fluid, they expand and the area swells. There are two kinds of edema. In the type called pitting edema, applying pressure to the swollen area causes an indentation that persists after the pressure is released. In non-pitting edema, there is no persistent indentation after pressure is applied.
Edema is a swelling caused by the abnormal buildup of fluid in the body. The fluid collects under the skin within the tissues that are outside of the circulatory system. Edema is most common in the feet and legs, but it can occur in the hands, arms, face, abdomen, where it's called ascites, and around the lungs, where it's called pleural effusion. Cause: cancer, especially kidney, liver, or ovarian cancers. Other medications, including corticosteroids, hormone replacement medications, anti-inflammatory drugs such as ibuprofen or naproxen, and some blood pressure medications. Low levels of proteins in the blood, inactivity which can cause fluid to collect in the feet and legs, problems with kidney, liver, or heart function. In Ecuador, we have another cause of interstitial fluid disease that is associated with altitude sickness. Acute mountain sickness can progress to high altitude pulmonary edema or high altitude cerebral edema, which are potentially fatal. Thank you for your attention.